Looking at this next problem. So again, there's two different forms we want to get these equations into. Either the logarithm equals some constant, or the log of something equals the log of something else. Looking at this equation, I can see that I'm going to want to get it into this form because I actually have a constant here, this constant 3. So to get it into that form, I need to have one logarithm written on the left-hand side. And this is where the properties of logarithms really help to solve. So we can use that addition property that lets us combine these logarithms by multiplying their arguments since they both have that same base of 2. I'm just going to simplify what's inside the parentheses. So this gives me t squared plus 2t. And now, if you look back at our steps, once we have it isolated into that form, you change this into exponential form. So changing it into exponential form, 2 to the third power equals 2t, or t squared plus 2t. And now again, we're looking at a problem that we've learned about previously. 2 cubed is 8. I have a quadratic, so I need to get everything onto one side and set the other side equal to 0. And then what I'll do is I'll either solve this by the quadratic formula or by factoring. I'm going to factor this. So this gives me t plus 4 times t minus 2. So I find that t equals negative 4 or t equals 2. So now I need to actually check. So let's check t equals negative 4. When I go back to my original equation, I have log base 2 of negative 4 plus log base 2 of negative 4 plus 2. Does that equal 3? Well, right off the bat, I see an issue. We're taking the logarithm of a negative number. You can't do that because, again, the domain of logarithms is whatever you're taking the argument of must be greater than 0. So right off the bat, this is undefined. So t minus 4 is not a solution. So that means that it was one of our extraneous solutions. So that's cut out. Now let's check t equals 2. When I substitute that in, I get log base 2 of 2 plus log base 2 of 2 plus 2. Does that equal 3? Well, log base 2 of 2 is 1 because 2 to what power is 2? And that's 1. This simplifies to log base 2 of 4. Log base 2 of 4 is 2 to what power is 4? And that's 2. And I get 3 equals 3. So that checks. So our solution is just 2. All right, let's keep on going. So if you feel like you are starting getting the hang of this, I really recommend pausing this video, trying to work out some of these problems on your own, and then unpausing it and seeing how I'm doing them. So again, we want to get this into one of two forms. You can see that this is going to be able to be written in that first form because I have this constant, and luckily it's already in that first form for me where I have the logarithm isolated on the left-hand side. Okay, so when I do this, I'm going to change it to an exponential form, so 3 squared equals x squared minus 8, x. 3 squared is 9. Get everything on the same side. And now I'll see if I can either factor this or use the quadratic formula. And I believe this can be factored. So this becomes x minus 9 times x plus 1. So I get for my solutions that x equals 9 or x equals negative 1. Now I need to actually check these. And again, when you check, you always go to the original formula. So let's first check x equals negative 1. So this gives me log base 3 of negative 1 squared minus 8 times negative 1. Does that equal 2? Log base 3 of negative 1 squared is 1. Negative 8 times negative 1 becomes a positive 8. So I get log base 3 of 9. Does that equal 2? And the answer is, so 3 to what power is 9? 2. So that checks. So even though our answer is a negative value, this x equals -1, it actually worked out because, again, the domain of a logarithm is whatever you're taking the logarithm of has to be greater than -1 or greater than 0. So when I substituted in this -1, that argument became 9, which is a positive number. Now let's see what happens when I check x equals 9. When I substitute that in, I get log base 3 of 9 squared minus 8 times 9. Does that equal 2? So I get log base 3 of 81 minus 72. Does that equal 2? Log base 3 of 9. Does that equal 2? And the answer is yes, 2 equals 2. So that also checks out. So in this case, I actually have two answers, -1 and 9, and both of them checked. Let's look at one last logarithmic equation, and then we'll jump into exponential equations. So again, we have logarithmic equation where we have logarithms. So we want to get the form or equation into one of two forms. And in this case, because of this constant here, I'm going to get this equation into this form. So again, looking at that first form, we need to get all of the logarithms onto one side of the equal sign and combine them so that they're written as one single logarithm, so that we have the logarithm on the left and then a constant on the right. So what I'm going to do is I'm going to move this logarithm over by subtracting it from both sides. So that gives me the logarithm base 2 of 3m plus 1 minus the logarithm base 2 of m minus 3 equals 2. So again, I just subtracted this logarithm from both sides. So now at least I have this part where I have the constant on one side, but I still need to get on the left-hand side of the equal sign those combined into one logarithm. And this is where I can use that quotient property. So this is, since these are both log base 2, I can rewrite these as 3m plus 1 divided by m minus 3 as a single logarithm. Now I have it in that form. So now I'm going to change this into exponential. So I get 2 to the second power equals 3m plus 1 over m minus 3. 2 squared is 4. All right, so I'm going to get this m minus 3 from out of being in the denominator. So I'm going to multiply both sides by m minus 3. That will reduce that there. So this leaves me on the left-hand side with 4m minus 12 when I distribute this 4 through equals 3m plus 1. Get all of the m's on the same side, so I'm going to subtract 3m from both sides. When I do that, I'm left with just a 1m on this side. And then I'll move that 12 over to the other side by adding 12 to both sides, and that leaves me with m equals 13. And I'll leave the check up to you, but I will tell you it does check. So for more examples over solving logarithmic equations, these are two great sites that you can go to that have more examples for you, so I really recommend you go ahead and hit those up.